When an object needs its physical properties specified in order for a dynamic simulation to be successful, those values will be entered and adjusted in something Reactor refers to as the property editor. In this video, we'll take a look at some of the important controls and settings you'll find inside the editor. Using a file named Property Editor, let's see what we can do. Now, the editable physical properties on an object can be accessed in a couple of different ways. Using the pull-down menu at the top of the interface, you could choose Animation, then head down to Reactor, then over to the right, choosing Open Property Editor. You could also go into the Utilities tab in the Command Panel. Clicking on the name Reactor, then heading down to the tab down at the bottom entitled Properties. There's also the Quad menu that you can use, accessed by holding down the Alt and Shift keys, then simply right-clicking on the screen. When the menu opens up, in the lower right-hand quadrant, you choose Open Property Editor. Or, as a fourth option, you could utilize the Reactor toolbar if you have it open, like we do here, heading all the way down to the bottom, then choosing the fourth icon up. Having the dialog now open, your three primary properties that'll control the way an object moves around the scene and how it behaves when coming into contact with other objects are mass, friction, and elasticity. You'll find those right at the top under Physical Properties. Mass is basically an object's weight, with higher values making the object appear heavier during the simulation. When an object has a mass of 0, the default value, that object will remain fixed in space during the simulation, with other objects in the scene being able to collide with it and realistically reacting to that collision. Friction affects how an object responds movement-wise to any other surfaces it might come into contact with. Higher amounts of friction will make an object appear to grab onto those other surfaces, appearing not to slide as easily over those objects. So slippery objects would have a low or no friction value, while rougher, more grabbing surfaces should be given a higher friction amount. Typically, you'll keep this number between 0 and 1, although the setting does go as high as 5. The elasticity setting controls how bouncy an object is, with higher values creating a bouncier reaction when that object comes into contact with something else in the simulation. This setting too has a maximum value of 5, although like with friction, you'll usually want to keep your elasticity number somewhere between 0 and 1. The inactive checkbox is a big one in that when turned on and applied to a rigid body object, that object will begin the animation in an inactive state, meaning that in order for that object to move in some way during the sim, it must interact with something else in the scene. An example would be something like a blade on a windmill. That blade sitting in a resting position until either coming into contact with an object, like maybe an airplane running into it, or being influenced by an external force, like let's say wind. Unyielding is another very important control to understand when you're including something in your simulation that's already been animated or manually keyframed, in other words. In the case of an already animated object, you'll want to make sure that unyielding is turned on. Doing so will allow other objects in the simulation to recognize it, being able to collide with it, and being able to feel and react to being hit by that unyielding object. What's important to realize, though, is that an unyielding object's movement will be exclusively governed by whatever normal keyframed action has been applied to it prior to making its way into the simulation. So an unyielding object can affect other objects within a simulation, but its movements and behavior will only be affected by how it's been manually animated outside of the simulation. An example of an unyielding object might be something like a bowling ball whose movements toward the pins has been hand-keyed in, but whose effect on hitting those pins is all automatically simulated by the calculations made by Reactor's physics engine. So make sense? An unyielding object moves and reacts only by the way of how it's been manually keyed. The simulation geometry category, about halfway down, is another big one. These settings deal with how the shape of an object is calculated or represented during a simulation, some options representing the actual shape of an object more accurately than others. That accuracy, though, coming at the expense of a longer calculation time. The bounding options, box and sphere, place an invisible, lower detail, less accurate bounding shape around an object, the extent of that fill-in shape being determined by the object's dimensions. Now for basic shapes, like the ball and box in our scene, the bounding option will work just fine. Quicker calculations, but maybe not quite as accurate. Let's go ahead and make those changes. With the green ball selected, we'll change its simulation geometry to bounding sphere. Leaving the property editor open, we can now select the blue cube. For this object, we'll take its simulation geometry to bounding box. The default setting for simulation geometry, Mesh Convex Hull, is ideal for more detailed solid objects, whose surface might not be as accurately calculated using just a simple bounding box. An example of that might be the red ball in the middle of the back row. Because of the variations in its topology, though taking longer to render, Convex Hull would probably be the better way to go. The setting 2 options down from that, Concave Mesh, is designed for objects containing some kind of negative space, which could be either a kind of carved out area on an object or an open or empty space altogether. Here, an extra level of calculation takes place to ensure that those open areas are seen and accurately responsive during a simulation. Both the objects on the far left of our scene would constitute concave mesh objects. Now we can actually change both of them at the same time by merely having them both selected when we make the switch over. I'll window both, then back in the property editor, we'll make the change down to concave mesh. Now the last option under simulation geometry is proxy. A proxy object is basically a stand-in object. Using something in your scene, usually another object of the same shape but with less detail, to calculate the needed simulated movement for the higher detailed object. The 2 objects in the lower right-hand corner of our screen would serve as good examples of being able to use a stand-in proxy. The pink object has a good deal more geometry in it than the orange object just to its side. In fact, the difference in face count is 3,300 versus 440. Because both surfaces are basically the same shape, we can use the orange object as a proxy stand-in for the pink one. Here's how we'll do that. We'll first select the pink object. Because of the negative space up around its neck, we'll then choose Proxy Convex Hull. Then, about an inch below that, to the right of the name Proxy, we'll click on the None button. Now this is our way of signaling to Max that we're now going to pick that stand-in proxy object. With that button down, we can now carefully click on the orange one. Once done correctly, you'll now read the name Orange Proxy Pin to the left of the name Proxy. Now, during any upcoming simulations, the lighter weight orange object will be substituted for the heavier weight pink one. Done so for the intention of speeding up the simulation. So there you go with a bunch of stuff on getting the most out of an object's property editor. When next running a simulation, you'll now know the exact settings to use in order to get both the quickest and most accurate sim.